Assalamualaikum and greetings to all. So for today, uh, since there are requests for recording explanation for this chapter, so I just do a simple recording. Okay, here. Hopefully it may help you in understanding more this chapter in how we want to map from the ERD model to a table relationship. So we start. So for the covered topic, first is the introduction, a big introduction about the how the correspondence relation table with the ER model, and the important things you need to understand about the keys. And then we will go to the second topic, which is how we do the mapping. There are several steps and rules, which we may refer to the company ERD examples. And then the final one is how we will map the EERD. Okay, in this subtopic, there will two part. Okay, so the first part is a very simple mapping between the subclasses and also the superclasses. Okay, so we will do the details on the EERD mapping in the next chapter. So let's recap back what you had learned previously in mapping the ERD to the relation diagram or relation table. So briefly in the introduction, it will explain about the definition of the relation and how important of the keys in this topic. Okay. So the relation as definition is a name and then a two-dimensional table of data. And the table is made up of rows of records and columns that have an attribute or field. Okay, and not all tables are qualified as a relation. So what is the requirement in qualification of the tables that are qualified as a relation? First, the requirement, the tables, every relation has a unique name. So in order to construct this relation table, so you need to make sure that the relations has a unique name. And every table value is atomic, which means it's not a multi-value item, or the value is not a composite or multi-valued. And every row is unique, which means you can't have two rows with exactly the same value for all field records. Okay, it will be a redundant data there. And attributes which are correspondent with the column in the table have a unique name, and the order of the column is irrelevant and the order of the row also is irrelevant. So what is the atomic value that I mentioned earlier? So these are examples of a not an atomic value. This value of items have many value in a single row. So this is a not atomic value. So atomic value, that's mean in your table for every row by column or position of the cell there exists only one value, not an array or not a list of value. Okay, so you must remember this. Correspondence with ER model, which mean the relations or the tables correspondent with the entity types and with many-to-many relationship types. The row correspondent with the entity instance and with many-to-many relationship instance, and column correspondent with the attribute. Okay, that is what I mean by correspondent with ER model. So the next things that important in this creating the ER diagram to a relation table is the key. Okay, the keys are special fields that serve two main purposes. first is the primary key, which are unique. Okay. Examples, if we include employee number, social security number, etc., this is how we can guarantee that all rows are unique. Okay. And another one is the foreign key, that are identifier that enable a dependent relation on the many side of relationship to refer to its parent relation on the one side of the relationship. Okay, so the keys can be simple, a single field, or a composite, more than one field. This is the composite keys is the combo, okay, of the two foreign key, for examples. Okay, we may see this in the next examples that we will go through step by steps. And the keys usually are used as indexes to speed up the response to the user queries. That's why we need to have a keys in the relation table. So let's do the mapping ERD to a schema diagram, okay, by using the ERD company example. So here is the company ERD examples where we have employee, department, and we have the weak entity here, okay, and also we have a recursive relationship here, okay, and there are many to one to many relationship, one to one relationship, and also many to many relationship. So make sure if you do the ERG diagram, again I remind you to fix with a one type of notation symbol. So this is the chain notation symbols. Okay, we have these attributes, entities, okay, and then the relationship, okay, one to one. This is how we do the one to one, okay, and this is how we write one to many using one n, okay, and many to many we use the mn, okay, and the participation, okay, we have a full participation with we indicates with a double line and a single line for a optional or partially participation. Okay, so this is a total participation and this is the optional participation. So that is the main notation that you need to understand, and you may refer to the fundamentals of database system textbooks that I already upload in the Putra Blast for more reference about this. Okay, so now let me proceed with the mapping. Okay, this is how the output will come from the ERD diagram, result from the mapping of the company ER. Okay, and here are the steps. Okay, we have step 1 until step 8, where the 8 is focused on the EERD. Okay, in order to come until this step, you need to do 1 to 7 steps. Okay, so you have to follow the step by step. Okay, identify all of this in the ER diagram. Okay, so let's see. Based on the ER diagram, okay, first step is mapping the regular entities to relations. So for regular entities, we will create a relation, then include a simple entity attributes and indicates its primary key. So let's identify the regular entities. So where is the regular entities? Okay, so we have here the regular entity will be employee. Okay, so it's also we can be the department, and also project. Okay, so dependent. Dependent is not a regular entity. Okay, because it is a weak entity. Okay, so this is the weak entity. So we will not map this, we will KIV for this for a while. We will do for the employee and department and also the project. So we go through one by one, okay? So next. So for regular entities, create a relation that include the simple entity attributes and indicates its primary key. So this is how we create the relation. We have the entity name. We put here as the relation table name, okay? And we have this column. This column is the where we put all the attribute. Okay. Okay. So the attribute we have SSN. Okay, birth date. And here, name is the composite attribute. Okay, therefore, we will include the simple entity attribute of name, such as F name, middle name, and L name. Okay, so we since the regular entities mapping is include the simple entity, so if we found the composite entity here, we will put their simple entity in the column here for the attribute. So we will put the F name, middle name, and also last name, address, salary, and sex. So after that, we need to indicate its primary key. How to indicate the primary key? You look to the entity. Here, the attribute, the SSN is the key attribute. The key attribute is the primary key. So we put the key attribute SSN as a primary key. So how to identify the primary key in the relation table? By underline the SSN or the key attribute. So next, let's create the rest of regular entity, which is the department. So as we can see here, the department have the attributes name, numbers, and location. Okay, so the location is a multi-value. The multi-valued attribute. Okay, so this multi-valued attribute is not a simple attribute, so we KIV for this. So we will not put this inside here because we will deal with this later. Okay, so we go for the left entity is name and numbers. Okay, so we put name and numbers. As you can see here, both have set as a key attribute. Okay, so both have a key key attribute, or we can say as name might be the partial key of the location, might be because this is the multi-value. Okay, you may refer back to the terminology what is called for the key attribute that have two like this. Okay, for reference. So if you are facing with this if you encounter with this situation, okay, so put the attribute here, name and number, and choose only one as the primary key in the department relation table. So you may choose name or number. So either one, you can put the underline, okay, for the primary key that you choose. So in this case, I choose number. So if you choose name, also can. Okay, so in this case I choose number. Okay, that's it's how we map the regular entity to relation. Okay, so next let's do uh, the next step, which is mapping the weak entity. Okay, in mapping the weak entity, there are rules. Okay, for weak entities, create a relation with its name, include its own attribute first. Okay, then the primary key of the entity is dependent on as a foreign key, and the primary key of the weak entity would be a mixture of foreign key and its own partial key. So let's see how we done with it. So let's identify first what is the weak entity. So here the weak entity notation can be identified by the entity that have a double rectangle like this. So dependent is the weak entity, which the correspondent entity is employee. Okay, so this is the dependent parents, or it dependent. We can say that this dependent is owned by employee. Okay, so let's see how we will name it. Okay, so we will do by draw the relation table here. Okay, and name it based on the weak entity name. Okay, so we name it as a dependent. So here, what is the primary key? In this order, to identify which primary key that we will use is, we will bound the primary key with the strong entity, so that the strong entity is referred to the owner entity. What is the owner entity? The owner entity is the employee. So in the dependent, put all the attributes that relates, okay, and then we create a foreign key that refer to the primary key of the owner, or the uh, the who is the dependent of this relation table, okay, of the weak entity. Who is the owner of the weak entity? So the owner of the weak entity is employee. So we create the ESSN. Okay, remember the attributes must be unique. So we rename it as ESSM, which we can refer as the employee SSN, as this is the foreign key. So we refer back to this primary key. Okay, so we done with mapping the weak entity. Okay, we done with the mapping with the weak entities. Now let's remapping the binary relationship one to one. Okay, so we will use these foreign key approaches. Okay, where one of the entity relationship is having a foreign key that refer to other entity primary key. So we use this approach to create the relation table one to one. So however, there are some of the rules here that we need to be considered in order to identify which foreign key that we need to create in the corresponding entity. So let we see how it will be. So first we identify the binary relationship So the binary relationship is 1-to-1. So the relationship 1-to-1 here we found the employee manage the department. So this is the relationship. Okay, 1-to-1. Employee manage the department, where the department have a total participation. Okay, here. So let's see how. So to apply this approach is by having a foreign key that refer to other entity primary key. So we have the employee and department as the corresponding entity. Okay, so here we have two choice where to put the foreign key, either at the employee, which refer to the department, okay, or we put the foreign key at the department, which refer to the employee. Okay, so we have two options here. We can put the foreign key at the employee, or we can put the foreign key at the department. Okay, so what we have to do is to choose which foreign key that we need to assign to which corresponding entity. So here we need to check the participation. So referring back to the ERD, there are full participation in the department. So department have a total participation in managing the employee. So we have the total participation at the department and optional or partial participation relationship of the employee. So what is mean? The total participation means that the department must be managed by manager. Means that every department must have manager. Department must have. Okay, but in the other sides, not every employee manage the department. Not every employee manage department. Okay, so let's go back to the option that we have in creating the foreign key approach. So we have the option. First option is the foreign key at the employee, which referring the department. So what's the relation means? Okay, if we put the foreign key in the employee that referring to the department number as the primary key, this relation means each of the employee will have department number. Okay, each of these employee have a department number. Okay, how about this? This relation, if we put the foreign key at the department, which referring the primary key in the employee, what this will mean? This relation means that department have the ID number of particular employee. So that particular employee is the manager. Okay. So the department have the ID number of particular employee. So if we refer back to these both option, so we have. So based on the relation which the department have the ID numbers of particular employee, so this particular employee is the manager. So if we refer back to the total participation, which department must have one manager. So from there we can keep track the manager. Okay. Okay, why not choose this one? Okay, if we choose this one, we will look into a scenario. For example, okay, if we choose this one, this will mean we have a department number, and we have the SSN. Let's say we have hundreds of employee. 1, employee 2, employee 3, 4, until 100. Okay, we have this kind of record. Only 10 employee is manager. Example here, only 10 employee 3 is a manager, is at the department 1. Employee 4 is a manager at department 2. But this one is this employee is not a manager, so this will be null. Sorry, I use mouse so it's quite challenge here. So it will be null. So if we have 90 employee with an, if only 10 of the 100 is an employee, so we have 90 employee with a null value. So this is the records of the department number compared to the second option we have. So this is not the right way, because we have a very much there are many the record will be have a null value here. That's why we don't use this kind of foreign key at this side of the corresponding entity. That's why we choose to put a foreign key at the department. So let's see. If we put the department have the foreign key, what it will be like this. We have a manager, okay, MNGESSN, okay, and we have name, department name. Okay, so if we have hundreds as employee and only 10 employee is a manager, they can be referenced by the manager SSN. So the manager SSN, we have manager 1, manager 2, manager 3 at department 3, at department 4, at department 5. So we doesn't have a null value here. So we can have manager number SSN number 4. Okay, so how to refer which employee this is? So this is the foreign key which refer to the SSN as the primary key. So from here we can see the details of the corresponding employee by looking at the other attributes such as name, address, and the other related attribute. So hopefully you understand why we choose to have the foreign key at the department. Okay, because there are a total participation between the department and also the employee. So if you have a total participation between one entity to the other entity, put the foreign key at the total participation. Okay. Okay, last but not least, for the for that relation, you have to include the simple attribute from the relationship in the relationship with the foreign key. So you must put also this start date. Okay, so in this dependent, okay, uh, in this department where the foreign key is, okay, we put the manager start date attribute. Okay, so this is also the important things, where the relationship, if it have its own attribute, you must put the attribute as well in the relation table where the foreign key is. Okay, so that is how we do for the step 3. So we're done with the step 3. Now let's move to the binary relationship 1 to n. So 1 to n, which means 1 too many. Okay, this is the popular approach for binary entity type 1n, and this is called the merge relation approach. So in this merge relation approach, we will include the foreign key of the entity at the n side and the primary key of the entity at the 1 side. So let's see. Uh, Identify the 1 to n relationship. So here is the 1 to n relationship. We have the corresponding entity is employee and also the department. Okay, in this step, we will put on the n side as the foreign key and the pk of the entity on the one side. So here, the corresponding entity will be the employee and the department. Okay, so the relationship employee work at the specific department. So the employee is the n side. The n side is at the corresponding entity employee. So we put the foreign key of the department number. So we put the department number here and referring to the primary key at the department. Okay. Why we put a foreign key at the n side, not at the one side? So this is because of the relationship refer that employee works upmost at one department and department has upmost or many employee. Okay. Okay. Why we don't put the foreign key at the department um, relation? Because if we put the DSSN here, okay, for example, we have DSSN is referred to the SSN, right? So for example, here we get the department number name. Sorry. For example, here, this is the department number. This is the number, right? Number. This one. Okay. So we put the DSSN. DSSN is the what we call social service number of the employee. So that we have the employee 1, we have employee 2, we have employee 3, we have employee 4, and we have the department number. Employee 1 work at department number 1, employee 2 work at number 1, employee 3 work at number 2, employee 4 work at number 2. So they will be a redundant record for the department number. Okay, that's why we not use this, this is not the right way to do the records. Okay, so that's why we put the department number at the employee to simplify the record and make the record not have too much redundancy. Okay, so let's take 5, okay, before we continue for the next step. okay, you may pause, okay, or proceed for the next explanation. Okay, now let's see what we have next in step 5, which is the mapping the binary relationship M to N. So this is the relationship to mapping this relationship M to N, many to many. We use the cross-reference or relationship approaches, which is we will include the foreign key of the entity on the N side as the primary key of the entity of the one side. So now let's identify where's the M to N relationship. So M to N relationship is here, which is the corresponding entity is employee and also the project. Okay, this is the relationship, the related relationship. So for M to N relationship, make another relation with the relationship name, include its own attribute if any, and PK both entity as FK. The combo of FK will make the primary key. So we must follow these rules. So this is the corresponding entity, employee, and also the project. So we already have the employee relation table with their attributes. Okay, so we have to create the project relation table with their attributes. Okay. So this is the project relation table with their attributes. As I mentioned earlier, if in the project ERD, we can see there are two key attributes. So for that, we choose either one as the primary key of this relation table. So for the project relation table, we have name, numbers, and location, where I choose the number as the primary key of this project relation table. So the corresponding entity is the project and also the employee. Okay, so we have this one and this one. So what the rules? The rules is create a new relation. The name of the new relation can be the name of the relationship ERD. So I name the relationship which is the work on. Okay, and this is where we can put the related uh, attributes. So the participating entity is the employee and the project. What is the primary key of them? And any attribute in the relationship? Okay, let's see what we have. So we have the works on, okay, as the relationship name. Okay, what the participating entity, employee, and also the project. What the primary key of them? The primary key is, what is the primary key of the participating entity? So the participating entity, the participating entity is employee and project. So their primary key is SSN, so that I create a foreign key of SSN, which is ESSN. So remember, this ESSN must be unique. Okay, this one I put like this. Okay, so this one I put like this. So it's unique. So ESSN is referring to the primary key. So then another corresponding entity, project. So project, what is the primary key of project? Number. So for the foreign key, I create the P number, refer to the project number. So I put the relationship here, foreign key to the primary key here. So next, this one is done, this one is done. Any attribute in the relationship? Yes. If you see in the ERD diagram, there are hours as the attribute of the work on relationship. So we put this attribute, simple attribute, into the corresponding uh, uh, relationship table here, which is we put here. Okay, so it's not done yet because the rule says that PK of both entity as the foreign key, the combo of foreign key will make the primary key. For these rules, which mean we have to underline both of these foreign key to be a primary key. Why have to make both a primary key? Let's see the example. This is since it is a many-to-many relationship, we cannot make only one of a primary key as a primary key. Okay, because the combo of this foreign key will become a unique, which therefore they both will be a primary key. So for example here, I cannot just put one single as a primary key because it cannot be unique for each of one. For example here, we have the employee number 1 working at project 101. And he also do a project 102. Okay, so if I just put one foreign primary key, this cannot be a primary key because they have a redundant. They are not unique. Okay, so you have to remember primary key must be unique. So that's why we combo both. Okay, I also cannot put project number as a primary key because one project can be done by more than one employee. Employee 1 can make project number 102. Employee 3 also can do project 102. So if I make this as a primary key, it cannot be because the project number are not unique. Okay, how we make it unique? We combo them. So both be the primary key. So this will be a unique one. This will be a unique number. This will be a unique set of primary key. That's why we put underline on this foreign key to make it as a combo primary key. Okay? Okay, that's we done with all those relationship, one to one, one to many, many to many. So now let's see what left. We have a multi-value attributes and also recursive relationship in the ERD. We go first for the mapping the multi-value attribute. So for this multi-value attribute, make a separate relation with an attribute of the same name. Then a primary key of the entity that is the attribute of S, the foreign key of this relation. Primary key is the foreign key itself. So it must be confusing here. So let's see how it be done. So let's identify the multi-valued attributes. So the multi-valued attributes here is this part. We have the location with the corresponding entity is the department. So let's see. So we have the corresponding entity is the department. Okay, and we have the location. Okay, create a new relation. Okay, I create the new relation here. The name of the new relation can be in relates with the name of the multi-valued and the corresponding entity type. So the multi-valued name is location. I name it as a location. The corresponding entity type is the department. So I put the location department. In this case is location and department. Therefore, the new relation name can be location department. Okay, next. Name attribute okay. Name the attribute same. Okay, we done with this. In this case, we will name the multi-value attribute as the D location. Okay, so the multi-valued, which is the location, we name it as D location. Okay, I name it as D location. Then look into the corresponding entity, which is the department. Make the primary key of the entity as the foreign key in the location department. What is the department primary key? Number. Okay, so I put it as a D number, as D number is the foreign key for the department number, primary key of the department. Okay, so just put D underscore the number as a foreign key as the D number. Finally, set both as PK. So we set both of them as a PK by underline the attributes here. So the numbers is the primary key, the location also the primary key. Why? So the situation is same as the M to N, where we have to set both of them as a primary key because they are a multi-value attribute, which means if at the location of there can be a multiple department at a many location. For example, department ERD can ERD R&D can be at USA. There also can be a department R&D at Malaysia. Okay, there can be a QA department at China. It can be a, a, a QC department at China. So both of them cannot be only either of them as a primary key because we want to make a unique. So we have to combo them. Therefore, it will be a unique combination. So that's why we uh, uh, cannot represent PK separately. If we represent them separately, this is not unique. If we present this separately as a primary key, this is not unique. Okay, so that's why we have to combo them to make it unique as a combo primary key. Okay, this is how we the step how we map the multi-value attribute. Okay, so we're done with the multi-value attribute. Now we go for the recursive relationship. For recursive relationship is a very simple. Just include the foreign key that is actually the primary key of the entity itself, but with a different name. So let's identify where is the recursive. The recursive is here, supervision, with the corresponding entity is the employee. So we go to the employee. We just rename the SSN as a supervisor, super SSN. So we identify the corresponding entity, which is in this case is the employee, at the FK entity which refer to the PK of the corresponding. So the PK is the SSN. So here we add the super SSN. So this is the foreign key. So we link to the primary key. Alright, so this is the output. Okay, if you follow this exercise step by step, you will be identified that I not complete one of the relationship which is in project, which relates with the department. So this is the how it is one-to-many relationship. So therefore, we will put the N, a foreign key at the project, which is the N, which corresponding to the primary key of the department. This is department is the corresponding entity between the department and project. Okay, So if you go through one by one from the start of this video until step 7, you will find that there are a missing place, missing relation between the project and also the department. So you may finish and figure out the answer, and make sure the answer will be like this. Okay, this is the final answer for the mapping. So let's take 5 before we proceed with the last step. Okay, you may pause the video, okay, for take 5, and then you may proceed with the next explanation with which is the last step. Okay, so we done until step 7, so let's go for the step 8. For the step 8 is for the ERD mapping. So this is a simple examples in how we map the superclass and also the subclasses. Okay, but the more details of how we map the superclass and also the uh, subclasses with a very different participation and cardinality, we will go through it in the next session. Okay, so as if you have this kind of ERD with a subclass, we have here hourly employee, salary employee, consultant, and each of the subclass we have a specific attribute. Okay, for hourly employee we have the hourly rate. The salaried employee we have annually salary and stock option, and consultant subclass we have the contract number and billing rate. Okay, and the disjoint here as their cardinality, and the participation is not a total but a partial. So let's see how it being mapped into a relation table. So here is how we map for the relation table, where we create the attributes, okay, and put all the we create the relation table based on their name of the subclasses, and put all the attribute. Okay, this is the attribute for the hourly employee, salaried employee, and also consultant, and then create the foreign key for each of the subclasses, which referring to the superclass, which is the employee number, and set them as the primary key of the relation. Okay, so this is how we do the mapping. So next, okay, that's all for the chapter today. So we will continue with the more EER mapping to relations. Okay, so hopefully this video will help you to more understand in how to do the mapping between the ERD to the relation table. Okay, see you. Okay, bye. Thank you. Assalamualaikum.